Hello and welcome back to Data Visualization using Python. In today's video, the first of section 3, we're going to begin looking at some more different data visualization methods. In this section, we're going to see how to use bar plots, scatter plots, histograms, and box plots to compare different kinds of data, whether that be small collections of numbers, correlated values, distributions, or statistical properties of distribution. Today's video, we're going to begin by grabbing some data from Fandango, the popular movie rating website, and investigate different movie scores using bar plots. So in this video, we're going to take a look at how to get this movie data into Python using pandas, how to plot some different movie scores using bar charts, and how to tweak the appearance of these bar charts. So we'll begin by actually downloading this data, which you can get from 538's GitHub repository at this URL. What you'll want to download from there is the Fandango score comparison CSV file. The README in this repository will give you a little bit of information as well about the different properties of the columns within this CSV data file. So let's load up Jupyter and begin. So we're going to begin, as usual, by importing pandas, numpy, and matplotlib. And then we're going to use pandas read csv method to actually load up this data. Then, if we use the head method on our data frame, we'll actually get another data frame returned here that just contains the first 5 rows. And you can see here we've got 22 different columns of different values. Some of them are ratings, some are normalized ratings, and some are just counts of how many times a movie's been rated. So let's compare a couple of different scores, normalized to between 0 and 5. The Rotten Tomatoes rating, the IMDb rating, and the Rotten Tomatoes user rather than critics rating. So because that head returns a data frame, we can actually plot the data frame itself that comes out of head. So rather than plotting hundreds of movies, let's just look at the first 5. So if we call the bar chart method, you'll see Pandas is smart enough to actually build up legend for you and plot all our various values, but it's not smart enough to actually label these things, and it's not smart enough to pick out which of these we're interested in. So if we want this thing labeled by the name of the film, we can pass x equals film, and there you can see we have our labels. And if we only want to investigate these scores here, well then we can do y equals rt norm, for example, to get one value, or you can pass in an iterable, in this case our little list called scores. And there you can see we have a nice little bar chart looking at the different values here. And you can see there's some interesting things going on. For example, normalized Rotten Tomatoes is often quite a bit lower. Some of the movies we see here, Do You Believe and Hot Tub Time Machine, so a kind of Christian movie and a goofy sex comedy. But for the other 3 different values are pretty similar. We can also generate horizontal bar charts just by using the bar h method, with the same kind of arguments as before. So if I do x equals film and y equals scores, you can see I get essentially the same plot, but with the horizontal bars instead. And if I give that, instead of being a y label, I make it an x label, there you can see it's exactly the same plot, just rotated onto its side. I can also change the color of my bars. So let's say I want to do, rather than blue, green, and red, I might want to do, let's say, yellow, red, and black. Kind of a weird color choice, but perhaps that's what we want here. And close up our function call. And this is colors. Oh, and you'll notice that there's been a warning with pandas. They've changed colors to color in the latest version, so we can fix that as it likes. And there you see we have yellow, red, and black as we requested. You can also change the fill inside here. So rather than having a solid color, I can give hatch to my bars. So for example, by passing hatch equals x, you can see it fills them in with an X-shaped hatching. I can also change the width of my bars with the width argument. So for example, if I want very, very skinny bars, I can give it a width of 0.1. This value goes anywhere from 0 to 1. And you can see there I get very skinny bars, or I can go with very fat bars with 1. And there you can see it actually fills in the entire amount of space that it has available for it. Now, what if, for example, you're not necessarily comparing values that are directly sort of competing with each other, as in these different ratings here, but say you want to actually add things up. So we're looking at 3 different counts of the votes here. What if I want to see, in addition to this, the total number of votes? Well, in that case, the bar chart provides us a nice extra argument here, simply called stacked. And if I set stacked to be equal to true here, then you can see it actually puts these things one on the other. So we have, in addition to being able to see the individual counts, the total count available to us here. Now you can see that IMDb has far more votes than any of these other competitors here. So if we want to see all of them together and not just have IMDb swamp things, we can actually use the log y equals true method. And this will make the logarithm of our plot. This will take our plot and show the log of the values. And it's actually log, not log y. And there you can see we have roughly 1,000 votes on Metacritic for Avengers 2, roughly 10,000 votes for Fandango, about 200,000 votes coming from IMDb. So you can actually see what's going on a little more realistically here, because we're no longer swamping these tiny vote counts. So for example, Do You Believe, if you look at Metacritic, has only about 30 votes on it compared to the thousands of votes on IMDb. So of course we weren't able to see that until we used logarithmic axes. So rather than stepping up in even spacings here in linear space, each of these big jumps here is multiplying by a factor of 10. It's a good way of showing data with logarithmic plots that has a wide dynamic range, like this data does.